exams 5, A and B. I didn't get a chance to finish them in the first video, so I'll go ahead and do that now. So we're going to start with 5.3a, where we're using variation of parameters to solve this Cauchy-Euler equation. Okay, and the complementary solution is already given, so we can start by putting this equation into standard form. So dividing through by that by the x squared is going to give you y double prime minus 2 over x y prime minus 4y equals x to the 1/2 power. Okay, and let's go ahead and calculate our Wronskian. So the Wronskian here is going to be x to the -1, x to the 4th, the -2. Okay, and when you do your little fishy, you should get 5x squared. Okay, so now we can actually start solving the equation. So for our u1, I'm going to get the integral of our y2, so our x to the 4th, times our function here, x to the 1/2 times our f function, divided by our Wronskian, which is 5x squared dx. This simplifies to the integral of 1/5 x to the 5 over 2. Okay, and when you evaluate that, you should get, sorry, that is negative since we're dealing with the first one, a -2 over 35 times x to the 7 over 2. Okay, so now we can start on our u2, which is pretty much the same thing without the negative sign. So our y1, which is our x to the -1, times our function here, x to the 1/2, divided by 5x squared dx. This then simplifies down to 1/5 times x to the -5/2. And when you integrate, you should get 2 over 15 x to the -3 over 2. Okay, and now we're going to multiply them by their respective y1 function. So you have your u1 times your y1, which is your -2 over 35 times x to the 7 over 2. That's being multiplied by your x to the 4, and then plus 2 over 15 x to the -3 over 2, be multiplied by our x to the -1. Okay, and then since we're doing our general solution, we're going to include the solution that was given to us here, plus c2 x to the 4th, and when you simplify this down, you get y equals c1 x to the -1 plus c2 x to the 4 minus 4 over 21 x to the 5 over 2. Okay, so that is 5.3a. Okay, so I'm going to start on 5.1b. So 5.1b, we're being asked to use the method of undetermined coefficients to solve this equation. So we have our y prime plus 6y prime plus 25y equals 3e to the -2 plus 5x plus 2. Okay, so at first we need to solve for our complementary solution. So our auxiliary equation looks like this. And this does not factor into anything nice and easy and fun, but when you do factor this, you should get -3 plus or minus 4i. If you don't, let me know, and we can go over how to use auxiliary equations again. So now that we have our auxiliary equation, we know that our complementary solution is going to look like this. Okay, so now that we have our complementary solution, we can start doing the method of undetermined coefficients. So based upon our driving function, we are going to assume that our particular solution takes the form of some constant a times e to the negative 2x plus some constant b x plus some constant. Okay, so we're going to take the first derivative, going to give us negative 2a e to the negative 2x plus b. Our second derivative gives us positive 4a e to the negative 2x. Okay, and now we're just going to plug in all these values. So for our y double prime, we have our 4a e to the negative 2x plus 6 times our y prime here, so negative 12a e to the negative 2 plus 6b, and then plus 25a e to the negative 2x plus 25bx plus 25c. Okay, and this is all equal to our original driving function, 3e to the negative 2x plus 5x plus 2. Okay, so now we're going to develop a system of equations that we can use to solve for all of these coefficients here. So I'm going to start with our with our e terms. So we have 4a minus 12a plus 25a equals 3. Okay, and from this you can get that a equals 3/17. Okay, so now let's do the terms with an x in them. So we have 25bx, and that's it. Okay, so you have 25bx equals 5. Well, x, I guess, but the x's go away. Okay, so you get that b equals 1/5. Okay, now we can do the constant terms, which is 6b plus 25c equals 2. So we already know b, so 6/5 plus 25c equals 2, and that leads us to c equals 4/125. Okay, and now that we have all of our coefficients, I'm going to make a little bit of room, and I'm going to rewrite the final solution. And so we have all our coefficients, so our y is going to equal our complementary solution, which was e to the negative 3x times c1 cosine 4x plus c2 sine 4x Okay, and now plus what we just found out, which is 3 over 17 e to the negative 2x plus 1 over 5 x plus 4 over 125. And that is the solution. And that is the solution to this problem. Okay, so I'll clear all of this and we can get started on the next problem. Okay, so the next is 5.2b. It's already in standard form, so that's great. And we're going to solve it using the variation of parameters. Okay, so let's start by doing our characteristic equation. Okay, so that's going to look like m squared minus 4 equals 0. And you factor this out. You're taking the square root of 2, so you get m equals plus or minus 2, which means that our complementary solution looks like this. And don't forget your constants. Okay, now that we have our complementary solution, we can start solving using the variation of parameters. So the first thing we're going to do is take the Wronskian. So we have e to the negative 2x, e to the 2x, negative 2e to the negative 2x, and 2e to the 2x. Okay, and when you calculate this, you're going to get negative 4. Okay, so for our u1, we have our e to the negative 2x, and then times our driving function here, which is our 16 e to the 2x, divided by that negative 4 dx. So your negative 2x and your positive 2x there cancel out. Well, they don't cancel out. They make that term 1. So you just have the integral of 4. And keep in mind this was negative to begin with, and we have a negative 4, so it's going to come out positive. So the integral of 4 dx is just 4x, and that is our u1. So for our u2, I'm going to use e to the 2x, and then times that 16 e 2x divided by negative 4 dx. Sorry, let me get a sip of water real fast. Okay, so when you multiply this through, sorry, u2 equals the integral of 16e to 4x divided by 4. So you have 4e to the 4x here, which is going to be just e to the 4x, and don't forget your negative signs. If it's negative, e to the 4x is your u2. So your yp then is your y1 times your u1. So we get 4x times e to the 2x, and then plus negative e to the 4x times e to the negative 2x. Okay. And so our y general is the whole thing. So we have our complementary solution, c1 e to the 2x plus c2 e to the negative 2x plus 4x e to the 2x. And then you have your e to the 2x from this part right here, but that can get absorbed by this constant, so we can write our general solution as this. Okay, so I'm going to make a little bit of room, and then we can start solving the initial value problem. Okay, so we solve that our y equals 4e to the 2x times x plus c1 e to the 2x plus c2 e to the negative 2x. Okay, so our y prime then is going to equal 8 e to the 2x x plus 4e to the 2x plus 2 times c1 e to the 2x minus 2e to the negative 2x. Okay, and so now we can create a system of equations to solve for those coefficients there. So we know that y of 0 equals 3, so 3 equals we have 0 here, and plus c1 plus c2. Okay, so c1 plus c2 equals 3. Now we can plug in our y prime of 0 equals 2. So 2 equals, again, this term is 0, and then plus 4 plus 2 c1, oh, I forgot my c2, plus negative 2 c2. Okay, So when you subtract this 4, get a negative 2 equals 2c1 plus negative 2c2. Okay, so if you divide everything by 2 here, or negative 2 if you'd like, you get minus c1 plus c2. Okay, so now we can look at this equation up here. And let's subtract, well, let's add these equations. So we have 3 plus c1 plus c2. Okay, so if we add these equations, we get 4 equals 2c2, or c2 equals 2, meaning our c1 equals 1, because we know that c1 plus c2 equals 3. Okay, so now that we have those coefficients, we can write out the whole answer, which is y equals 4e to the 2x plus e to the 2x plus 2e to the negative 2x. Okay, and that is 5.2. We'll get rid of this and we can do the last one. Okay, so the last one is a Cauchy-Euler equation that we're solving using the variation of parameters. So the first thing we want to do is put it into standard form. So we have y double prime. I always want to say plus, and it's, there we go. Y double prime minus 4 over x y prime plus 4y divided by x squared equals 1 over x. Okay, so there is our equation in standard form, and we're given the complementary equation up here. Okay, so we can go ahead and take our Wronskian. So we have x and then x to the fourth. First derivative is going to give you 1, and then 4x to the 3 power. Okay, so that equals 4x to the fourth minus x to the fourth, or 3x to the fourth. Okay, so that's your Wronskian value. So our u1 is going to equal the negative integral of our y1 x to the negative 1, and then divided by our Wronskian, 3x to the fourth. So our x to the fourths go away, and we just have 1 over 3x to differentiate, which is going to give us negative 1/3 times the natural log of x. Okay, so now we can start on our u2, which is our x term times our f function here. This is our driving function once we put it in standard form, so it's right here, and then divided by our 3x to the fourth, integrating. Obviously, these two terms make a factor of 1, and we're integrating 1 over 3x to the fourth, which should give you 1 -1/9. X. To the -3. Okay, so now we can write out our particular solution. So yp is going to equal -1/3 ln of x. Actually, let's write out our general solution since we can. 1/3 ln of x plus c1 x plus c2 x to the 4th. And I want to say that your c1 here absorbed this term because when you multiply it by x to the 4th times x to the 4th, you get -1/9 x. So this becomes c1 plus 1/9. And being that c1 is an arbitrary constant, it doesn't matter, and you can just leave it as an arbitrary constant. Okay, so, and I do believe this needs an x as well. Okay, so that is the general solution. And let me know if you have any problems or any questions.